Suppose we have two lines, and all we know about them is their slopes, like these two lines here. How can we find the measure of the angle, theta, between these two lines just based on those two slope values? All right, see how we can do this. First, let's let the angles of inclination of the two lines be theta 1 and theta 2. We're going to need those to derive our answer, but they won't actually be a part of the final formula. Next, notice that theta 1 plus theta equals theta 2, since the sum of the measures of two angles in a triangle is equal to the measure of its remote exterior angle. Right, so from here, I'm just going to rearrange this, right? Because theta is the angle that I want, right? So theta is equal to theta 2 minus theta 1. Now, take the tangent of both sides, right? The tangent of our angle is equal to the tangent of the difference of theta 2 and theta 1. Now, I'm going to use the tangent difference formula, turn that right side into this. It's tangent theta 2 minus tangent theta 1 over 1 plus tangent theta 1 times tangent theta 2. Tangent theta 2 and tangent theta 1, those are the tangents of the angles of inclinations of our two lines. Those are just the slopes, right? That's how we define a slope. So if I put m1 and m2 in there, my equation becomes tangent of theta is equal to m2 minus m1 over 1 plus m1 times m2. And that's our formula, right? That's a formula. If you want the angle, right, obviously this is a formula for the tangent of the angle. If you want the angle itself, you just take the inverse tangent of both sides. So I've got some technicalities here that you need to be aware of. This gives us the angle between the two lines measured counterclockwise, where m1 is the slope of the initial side and m2 is the slope of the terminal side. You got to get them in the right order. If you don't get them in the right order, you're going to get the other angle, right? You'll get this angle here, which obviously isn't the end of the world. The angle that we want is 180 degrees minus that one. But that only works if you know which angle you've got, and you need to do that, right? So just keep in mind, right? It does matter which line slope gets to be m2 versus m1. If you think back to your high school algebra class, maybe a college intermediate algebra class, you learned about a relationship between the slopes of perpendicular lines. And I know when I teach this class, I just tell students what it is. Based on what students know at that point, it's a little beyond them to prove that that relationship works. But based on our formula here, we can do this now, right? If the lines are perpendicular, then theta must be 90 degrees. And if theta equals 90 degrees, then the tangent of 90 degrees is undefined. Right? Well, if the left-hand side is undefined, then the right-hand side has to be undefined. And the only way the right-hand side is undefined is when its denominator is equal to 0. Right? So if I take this equation and I solve it for m1, right, subtract 1 from both sides, divide both sides by m2, you get this relationship. Right? And this is the relationship you learned again back in that earlier algebra class. If two lines are perpendicular, then their slopes are negative reciprocals of each other. And that's exactly what we're seeing here. So in our next lecture, we're going to take a look at ways that we can look at a segment, say, okay, suppose I want to take this segment and divide it in half. What's the location of the coordinates of the midpoint of this segment? Then we're going to take that idea and we're going to generalize. We're going to say, look, what if I want to find a point that's some other ratio of the total distance along the line? For example, what if I want to find a point that's 1/5 of the way between the two endpoints, or 2/3 of the way between the two endpoints? Right? We'll see how we can come up with a really pretty simple formula to calculate the location of those points.